3.2.17. Alright, so this is one of the conditional probability questions out of 3.2, and right here is the formula for that. The probability of event A given event B equals the probability of A and B both happening divided by the probability of B. Alright, let's have a look at the question. In the general population, 1 woman in 8 will develop breast cancer. So I'm going to use BC for breast cancer. In the general population, the probability of getting breast cancer for a woman is 1 out of 8. Research has shown that 1 woman in 600 carries a mutation of the BRCA gene. Alright, so I'm just going to call it probability of BRCA 1 in 600. It's really the probability of a mutation of this, but we just need to know what we're talking about when we write the symbols down. Okay, the last part it tells us is 7 out of 10 women with this mutation develop breast cancer. So I mean, if you've got the mutation, then it's 7 out of 10 to get the breast cancer, right? So that means the probability of breast cancer, given that you have this BRCA gene, is 7 out of 10. Now notice this right here looks like this, right? Breast cancer given BRCA, A given B. Alright, so let's just move ahead and see what the questions are. So A, find the probability that a randomly selected woman will develop breast cancer given that she has a mutation of the BRCA gene. Well, that's exactly what this is right here, right? It's 7 out of 10, and the point of this question is just to check to make sure you understood what they're telling you. Okay, that you understand what how the word given is used and that kind of thing. Alright, so let's look at part B. Find the probability that a randomly selected woman will carry the mutation of the BRCA gene and will develop breast cancer. Alright, so our equation here has all the information in it we need, so I'm going to go ahead and write it down. So the probability again, so of A given B equals the probability of A and B divided by the probability of B. Now, if you look at the question here, part B again. Alright, what's the probability that she will carry the mutation, okay, and will develop breast cancer? In other words, the question is they're asking us for is the A and B right here, okay? The thing you need to see to get this right is they've given us the other two pieces of this equation. They've given us this one and this one. So we can plug these in and solve for the one we want, all right? So A and B, that is carry the mutation and develop breast cancer. Well, actually, it's develop breast cancer given that they have mutation, right? So A, let's write this over here. A is going to be, using a notation, A is going to be that they've got the BRCA notation, and then B is going to be that they develop breast cancer. Alright. Actually, I just did that backwards. That is annoying. Okay then. So, A is going to be that the woman develops breast cancer. B is going to be that she has this BRCA mutation. Alright. So, probability of A given B, they've already given us, is 7/10. Right? Probability that she develops breast cancer, given that she's got the mutation, 7 out of 10. Probability that both occur, that she's got the mutation and that she develops breast cancer, that's what we're asking about. And then the probability that she's got the mutation is this one over here, 1 out of 600. Okay? Okay. Now to solve this, we have to be careful about our rules about how the way this works, right? So we've got this big fraction over here, right? And you remember that when you divide by a fraction, it's the same thing as multiplying by the reciprocal, right? So this simplifies to the probability of A and B. So dividing by 1 over 600 is the same as multiplying by 600 over 1. Alright, so now we just have to divide both sides by 600. That gives us 7 over 6,000. So that's the answer as a fraction. They want it as a decimal, and that does in fact turn out to be 0.0012. All right, that's it for this one.